guys, here we are with 7.3. We're going to try to do day 1 and day 2 in the same video. For our first thing here, on day 1 we're just doing logarithms, and we're going to be converting from logarithms to exponential form, and from exponential form converting back to logarithms. Alright. So first off, a logarithm is the inverse to exponential equations. Alright, so you're going to see something like this, and we read this as log base 2 of 8 equals 3. Log base 2 of 8 equals 3. My personal preference is to spin this around and put the 3 equals on the other side. And that kind of helps me read it in a way that I can change it and convert it to exponential pretty quickly, pretty easily. So I'm going to spin this around, 3 equals on the other side. And to me now that says 3 is the power of 2 that gives me 8. 3 is the power of 2 that gives me, or that is 8. So now I know how to write it as an exponential. 3 is the power of 2, so 2 to the third, that gives me 8. Yep, and 2 to the third is 8. So here's also another little helpful chart or illustration here to use when you're converting between the two today on your assignments. Alright, if we spin it around, whatever's in the front of the equal sign is going to be your exponent. The base, the little, and the logs, the little number is the base, is going to be your base number, and then the big number at the end is your answer. So this little number actually is, the little number here is considered the base, and in an exponential form, base is actually the big number, but it's the base of the exponent. Okay, and then this goes up top, and then our answer 8 would go over there. Okay, so 2 is the power of 4 that gives me 16. So this is 4 squared equals 16. Okay, go ahead and pause and try to do this other two on your own. Okay, so we have 6 is the power of 3. So 3 to the 6th should equal 729. Negative 4 is the power of 4 that equals 1 over 256. So 4 to the negative 4th power equals 1 over 256. Alright, that's the first way, first type of problem we're going to be doing. Switching from log form to exponential form. Okay, now we're going to turn it around and go the other way. Okay, we're going to go from exponential form to log form. So here we have 2 to the third equals 8. Alright, so read it the other way. 3 is the power of 2 that gives me 8. And now I can plug that right back in. 3 equals log base 2 of 8. Alright, so 3 is the power of 15 that equals 3375. So I'm going to have 3 equals log base 15 of 3375. Okay, go ahead and pause and give those other two a shot. Alright, so over here, half is the power of 4 that equals 2. Half is the power of base 4 that gives me 2. And 1/3 is the power of 125 that equals 5. Alright, not too bad. Now, last type of problem for day 1 is evaluating these logs, evaluating logarithms, and they're going to keep pretty basic for you. Okay, so they're going to give you a log 16, log base 16 of 4. They might not even give you the equals y or equals x. Go ahead and add that on, equals y or equals x. Okay, I'll make it easier for you, I think. Step 1, turn it around. Y equals log base 16 of 4. Then we're going to use that to convert it to exponential form. So 16 to the y power equals 4. Y is the power of 16 that equals 4. 16 to the y equals 4. Now we're we're going to solve like we had been doing in previous lessons. We're going to convert to have the same base. So they could both go to 2's. They could also both stay with 4. So let's go with 4. That's going to be easier. 16 is 4 squared. So we have 4 squared to the y power equals 4. That's really 4 to the first. When we have power parenthesis power, we get to multiply. So we'll have 4 to the 2y equals 4 to the 1, or 4 to the first power. In order for that to be true, 2y needs to equal 1, and we'll get y equals a half. Okay? Looking at that right there, you try to do this one. Alright, so we're just going to throw down a random variable over here, x, y, z, whatever you want. Step 1, we spin it around. Okay, x is the power of 3, that gives me 81. So 3 to the x equals 81. We want to rewrite as powers of 3, get a common base. 81 is 3 to the, let's see, 3 times 3 is 9, times 3 is 27, times 3 again is 81, so 3 to the 4th. Alright, our exponents have to match, so x should be 4. And here's your homework for day number 1. Okay, day number 2 is just a full day designated for graphing. Okay, graphing log functions. To start off with f of x equals, we're going to start off easy here, start off small, log base 4 of x. Log base 4 of x. And this can be a y equals over here sometimes too. Okay, so step 1, identify the base. The base is the little number down below. That's 4. Okay? Next we need our 3 main points. Alright, 3 main points for graphing logs. Sometimes they're called anchor points. Okay, our 3 main points are going to be 1 over b, comma negative 1, 1 comma 0, and b comma 1. Very, 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 very important. Right there. Okay? 1 over b, comma negative 1, 1 comma 0, and b comma 1. Well, I already know what b is. b is 4, so go ahead and plug that in. 1/4, comma negative 1, 1, 0, and 4 comma negative 1. Do we have any translations or transformations to do? Transformations, Mr. Handke. I mean, there are some translations in there, but there's also a multiplier. That won't be a slide. Okay, transformations. So we have a times log base b of x minus h plus k. Do I have any of these? Do I have a multiplier? Do I have a number inside parentheses with x? Do I have a number outside of parentheses with x? No, I got nothing else. So there's no transformations. It's very basic. So we just graph those first 3 points. 1/4, comma negative 1, 1, 0, 4 comma 1. Okay, remember that logs are the inverse or the opposites of exponential. So this is going to partner up with y equals 4 to the x. Okay? If x was negative 1, y would have been 1/4. If x was 0, y would equal 1. If I put a 1 up there, we'd have 4. And look at that. Negative 1, comma 1/4, 1/4, comma negative 1. 0, 1, 1, 0, 1, 4, 4, 1. Okay? Our exponential would look like this and have an asymptote down here at y equals 0. Okay? After we flip this around and graph it over here, we have a vertical asymptote at x equals 0. So they're very, very similar, very closely related. Alright? Let's try another one. Log base 1/3 of x. So this time 1/3 is our base. Remember how our points go. 1 over b, comma negative 1, 1, 0, and b comma 1. Well, 1 over b, 1 over 1/3, Okay, that would actually equal 3. So 1 over 1/3 comma negative 1 is actually going to be 3 comma negative 1. So that's the only tricky part there with the fractional base, is getting that first one. The other ones shouldn't be too bad. 1 comma 0, and then whatever the base is, comma 1. Again, we don't have any translations, so we just graph it as is. Okay, and this time we can see that we're still having that asymptote here at x equals 0, but now we're kind of curling up this way instead of down. We're going off to positive infinity instead of down to negative infinity. Let's do one with some transformations. Okay? Y equals 2 times log base 4 of x plus 1. So our base is 4. So our points are 1 over 4, comma negative 1, 1, 0, and 4, 1. This time we do have some transformations, yes. We have a multiplier, times 2, and we have a plus 1 outside on the back. Okay, both of these are going to affect the y values. The only thing that would affect the x is if it's ever x parentheses. Okay? If it's inside the parentheses, then it's going to be the opposite of that to all of our x coordinates. Okay, this doesn't have parentheses, so I know it goes with the y. And the multiplier always goes on the y as well. So from my points, now I'm going to do these transformations to the y values. So all my y values get multiplied by 2 and then add 1. Okay, multiplication goes first. Couple ways to remember it. Okay, you're just reading it left to right. The times 2 comes first. Or your order of operations. Multiplication goes first. So you're going to do the multiplying first and then do your adding or subtracting to your y's. So all my y values times 2 and then add 1. So negative 1 times 2 is negative 2 plus 1. We're back at negative 1. 0 times 2 is 0, plus 1 is 1. 3 times 2 is 2, my fault, 1 times 2, okay, is 2, plus 1 is 3. My x's all stayed the same because I did not have anything that affected the x values. Okay? Our original points, 1/4, negative 1, 1, 0, and 4, 1. Oop, 4, 1 would be over here. This guy should be up here too. Okay, we'd look like this, and you can kind of see how we're bumped over, or bumped up and stretched out. Bumped up a little bit and stretched out. Let's take a look at one that uses our x values. Alright. Negative 2 times log base 3 of parentheses x minus 2. So base is 3. So we'll have 1 over 3, comma negative 1, 1, 0, and 3, 1. Okay, still following that same pattern to get those first 3 points every time. I told you it was a very important step. Okay, do we have any changes to make? Yes. Okay, we have a negative 2 multiplier, so the y values get times by negative 2. X minus 2 in parentheses, so I know this goes with the x. It's in parentheses, so I do the opposite. All the x values plus 2. So I add 2 to all my x values. 1/3 is now 2 and 1/3. 1 plus 2 is 3. 3 plus 2 is 5. On my y values, I'll get multiplied by negative 2. So negative 1 times negative 2, positive 2. 0 times negative 2, 0. 1 times negative 2, negative 2. Okay, so we should be stretched. We're going to be reflected over. We're going the opposite way again. And we're bumped 2 units to the right. Okay, so normally we would have an asymptote here at x equals 0 along the y-axis. We added 2 to all our x values, so we can do the same thing there. So we add 2 to our asymptote, x equals 2. Okay, this is another one with fractions. You can just take a peek at that if you need to, if you want to there. And your homework for part 2, day 2 here, is page 472, 37 to 46. 10 graphing problems. You're going to need graph paper for that. So if you don't have graph paper from class, you can just Google that and print off 10 graphs and get those done. 1 point a graph. Alright guys? Thanks for watching. Hopefully it helps.